Good morning and welcome to today's class. In today's class, we are supposed to finish something. What we are doing in the last class? Let's have a quick recap. What we are supposed to do, what we did in the last class. I hope every one of us remembers that.
Output characteristics,
Output characteristic of what?
transistors,
Output characteristics of transistors. That is what we were doing. Input characteristics and output characteristics. Those two graphs you must remember. And also
Okay, sir.
remember between what two things that graph was and what was the third thing that was constant. And I also give you a homework, a task to do at home. Do we recollect what was given to you? I had given you to read something before coming to the class today. Have you done that? No answer means you have not done. Yes or no?
Done, sir.
Done, sir. So what I'll do is I'll start with that same thing, sir. You must remember everything here in this table because everything is written in point-wise form, which I always love. So that makes things very clear. Emitter is of medium size and it is highly doped. We remember this.
Yes, sir.
Base is the smallest size. It is having low doping. Collector is of the largest side with medium doping. Never forget this because the question will come straight away from this. What is highly doped? What is very low in doping? What is medium in doping? The collector region is made physically larger than the emitter because collector has to dissipate much greater power. Do we understand this? Don't have to understand this. You will have to remember this. The collector has to dissipate a lot of power, and that is why it is made physically larger than the emitter. Transistor always work in the active region. Do we remember we had discussed 4 regions? Are?
Yes, sir.
What were the 4 regions? 4 regions. Again, you will have to go back in the past to see because it seems that you did not recollect. What were the 4 regions that we were talking about here?
Active, inverse active, cutoff, and saturation.
Everyone can read and tell me. You should not read and tell me because the third standard kid can do this. You will have to remember this. Do we understand this? Okay. Transistor consists of 2 words, transfer register. So it is transferring register. Signal is introduced at low resistance. Do you remember this? Input side that is low resistance and output is at high resistance. Do you remember this?
Sir.
Base is lightly doped. Transistor is a current operated device. This is just for your information. A question can come straight away from here. Will you remember this, bacha?
Yes, sir.
Okay. The next thing is uses of transistor, and the first use is transistor as an amplifier. We can amplify using a transistor. What is an amplifier? Everyone understand what's an amplifier? Do we know the meaning of amplifier, bacha?
Increasing amplitude.
Increasing amplitude? Correct. Amplify. Make it big. If I'm increase the amplitude of a signal without distorting its wave shape, if it is sine wave, it remains a sine wave, but the amplitude becomes more, so it becomes a bigger sine wave. That is what an amplifier is all about. This is the circuit of an amplifier. No one is going to ask you this circuit. No one is going to ask you this circuit. You just have to remember that this is the input and this is the output. What is the difference between the input and the output? What is the difference between the input and the output? Can anyone tell me that?
Waves are increased somewhat.
What?
Waves are increased somewhat.
Array, speak loudly, yaar. What's wrong with the voice?
Waves are
Increase the
increased
voice of
somewhat.
your microphone. Do you know how to increase the voice of your microphone from the meeting? Go to setting of audio. Go to audio setting. You know this or not? Go to audio setting, then go to your microphone and make the voice to maximum. Can you do that? So that I can hear you more correctly. I hope you know this, right? Go to the sound setting where you have that speaker. Then you go to microphone and then you make the volume of that microphone maximum so that I can hear your voice correctly. Now try. Now speak. Was the volume low?
Hello, sir.
Yes, sir. Make the volume maximum, bacha. Make it maximum. Okay. Now, that is what you must look at the diagram and see. I'm going to make the diagram bigger so that you can see on the screen bigger. Now, can anyone tell me what do we understand from the input and the output? Can anyone tell me? Looking at the diagram, everything is in the diagram, and that is what you need to understand, not the actual circuit of that. Can anyone tell me what is there that you can see? Array?
The waves are increased somewhat.
Waves are?
Increased somewhat from the amplifier entering
Okay.
and going out.
There is one more important thing that you have to see there.
The signals are changed opposite.
Yes, there is a phase difference of 180 degrees. Will you remember this?
Yes, sir.
Because the same question will come, they will give you an input and they will give you different outputs, and then you will have to understand which input will give you what output. So input and output, input will be smaller, output will be larger, but then there will be a phase difference of 180 degrees. Will you remember this, bacha?
Yes, sir.
That is what you need to remember this in what that is what you need to remember in this entire thing. As an amplifier, you don't need the diagram. They are not going to ask you the diagram. They are not going to draw that diagram and show it to you, because it becomes a very big question and that is not supposed to be known. Will you remember this? Shall I move forward in life?
Yes, sir.
Okay, so this is what you remember. This is what you draw. And this is what you keep in your head while you go into your examination hall. Now, have you written this? Drawn this?
Done, sir.
Done, sir? Then, sir, this thing, sir. Three types of configuration. Common base. Do we see common base here?
Yes, sir.
Common base, common emitter,
Common.
and common collector. Emitter, collector, base. Do we see this?
Yes, sir.
Emitter, collector, base. Do we see
Base.
this?
Yes, sir.
Base, collector. Look at
Collector.
the direction of diagram. Look at the direction of current. What type of this? What type of this is? PNP or NPN? Looking at the diagram, you can tell me it is PNP or NPN. Remember, the direction of current is always from P to N. Do we remember this?
Sir.
Do we remember this, bacha?
Yes, sir.
Yes or no? So tell me, what type of transistor is this? PNP or NPN?
PNP.
Well done. What about this one?
NPN.
What about this one?
NPN.
So you just have to remember this. Remember the diagram that are drawn, and I hope you would be good about it. Three configuration. If you want, you can draw the diagram. If you understand it, There is nothing more that you have to do. Now we come to the part where we have numericals coming in. Now these numericals will be, since I have three types of amplifiers: common base, CB, common emitter, CE, and common collector, CC. And therefore we have three categories of formulae. Shall we move on to those?
Yes, sir.
Yes, sir. No, sir. Then, sir, this thing, sir. And these are the questions that are going to come in your examination hall. You have to look at, you have to look at what? You have to look at the configuration, whether it is CB or CE or CC, because everything depends on the configuration. If you change the configuration, the input and the output changes. Do we understand this?
Yes, sir.
Okay. A stands for gain and I stands for current. So AI, sometimes it is known as alpha. Alpha stands for the current gain in common base configuration. Beta stands for the same thing but in common emitter. Gamma, you can call it for common collector. Will you remember this?
Yes, sir.
Now, it is common base, it is common base, it is common base, and therefore the output is IC and the input is IE. Do we understand this?
Yes, sir.
That is the value of alpha, and it is always less than 1 because the collector current is always less than the emitter current. Current gain is always less than 1 here. Will you remember this?
Yes, sir.
Coming to beta, which is current gain in the common emitter configuration. Remember, common emitter, common emitter, common emitter, common emitter. Your output is collector, your input is base, so it is IC divided by IB, and IC is always greater than IB, and therefore this gain is always greater than 1. Can I have some raised hand from everyone that we are in the class? Okay, great. Coming to gamma, it is common collector, common collector, common collector, common collector, and therefore the output is emitter current, input is base current. Remember, base current is always the smallest, and therefore this is always greater than 1. Is there any confusion in this? If there is any confusion, please raise your hand so that I can see any confusion. There is no confusion there? Yes or no?
No confusion, sir.
No confusion there. Then I will also make you understand the voltage gain, and then I'll give you time 1 minute to win it, so that you can what? You can write this. Voltage gain is AV, A standing for gain, V standing for voltage. Again, gain is always output divided by input, output divided by input. Voltage V is equal to IR. We remember this. V is equal to IR. V is equal to IR. Output current is IC. The load is RL. That is the load. So IC multiplied by RL, that will be the output voltage. IE multiplied by input resistance, that will be your input. Any doubts on this?
No, sir.
Any doubts on this?
No,
na?
sir.
Yes, sir. Then similar formula will come for common emitter. The only thing that has changed, numerator remains same, but the denominator becomes IB into RI. Here it becomes the numerator changes, but the denominator remains same. Do you understand this?
Yes, sir.
And sir, then sir, we can write a formula. We know the value of alpha from here. So we can write it in terms of alpha multiplied by RL by RI. We can write it beta multiplied by RL by RI. You can write here gamma multiplied by RL by RI. Then I'll give you a minute, 2 minutes, a minute to note it down. If you have any doubts, please ask. Else we will move forward after a minute. Have you done this thing? Okay, give you time. Shall we move ahead?
Yes, sir.
Okay, we have seen current gain. We have seen voltage gain. We have seen the relation between them. Now comes the third part, which is power gain. Everything is about power. Power gain, output divided by input. Everyone understands this? I square R is output. I square
Yes.
R is the input. I is IC in some case, IE in some case. I input is IC, IE in some case, IB in some case. Whatever happens, this will be the formula that we'll get. In common base, it will be alpha square RL by RI. In common emitter, beta square RL by RI. In common collector, gamma square RL by RI. Phase difference, you must remember between output and input. For common emitter, a common base, it is same phase. Common emitter, opposite phase. Common collector, same phase. Remember this because they will give you a diagram and they will give you the configuration and then they'll ask you what will be the output. You must remember. Do we understand this?
Yes, sir.
Application again, simple question will come straight away. Application of common basis for high frequency, common emitter for audible frequency, and common collector for impedance matching. Every information that I'm giving you will come in the examination hall. I'll give you a minute to note it down. Once you note it down, you should be able to recollect easy way, and that is the reason of you noting it down.
Done, sir.
Done, sir? Then, sir, the last thing on which question comes, and this is the relation between alpha, beta, and gamma. Alpha, beta, gamma. In case of common collector, we have alpha, relation between alpha and beta. Gamma is not there. In case of common emitter, we have beta and gamma. Alpha is not there. In case of common collector, beta is missing. Okay. So we all know that IE will be equal to IB plus IC. Yes or no?
Yes, sir.
Here also the same thing. Here also the same thing. Here also the same thing. Everyone knows this. Then I just put the values and simplify them. This is the relation between alpha and beta. You can either understand it in this form or you can understand it in this form. This is the relation between beta and gamma. This is the relation between alpha and gamma. You just have to remember these relations. Can you do that for me?
Okay.
You'll have to remember these relations. Can you do that?
Yes, sir.
Question, and I'll show you straightforward questions coming on this alpha, beta, and gamma. That time, please don't look back because people who look back in life will never move ahead in life. A minute to win it. I will give you a minute to note this down, and else we will move. We are done with the theory part. We are done with everything. We will move on and solve some questions that will give us more confidence. Have everyone noted it down? I don't see anyone writing. Note it down, everyone.
Done,
Okay.
sir.
Then we'll move further ahead. Golden key points. We have discussed most of these key points, and again, this particular topic, as you can see, the numericals are very less. Most of the questions are based on theory. Most of the questions are based on what you remember about that particular topic. That's it. Golden key points in transistor, charge carriers move from emitter to collector. You always know this. Emitter base is forward bias and collector base is reverse bias. We have already seen that. Yes or no?
Yes, sir.
In transistor, reverse bias is high as compared to forward biasing. We have more reverse biasing than forward biasing, so that the charge carrier move from emitter to base. Common emitter is widely used because it gives very large voltage. We have seen the use. Yes or no?
Yes,
And
sir.
power gain. Power gain and voltage gain is highest in case of common emitter. Negative feedback, we will see what this feedback is. You can just remember this. Negative feedback is used to stabilize the gain. Gain means current gain, voltage gain, or power gain. Common collector is used for impedance matching. When you want to match the impedance, you will use common collector. This is all that you need to remember. And I can't help you. Apart from this, you will have to remember this. Once you remember this, we can move on to some questions. First of all, we'll do some questions that cover this entire spectrum, and then we will move on to the previous year questions. Are we ready?
Ready, sir.
And again, if you don't remember the relations, you will not be able to solve the questions. If you remember the relations, you will be able to solve them easily. This is the first question that is going to be solved. In a transistor, the value of beta is 50. What is the value of alpha? If you don't remember the relation, it is gone. So remember the relation, it is on. I give you a minute to do it. Anyone with an answer?
Yes, sir.
What's the answer, sir?
0.998.
0.98 is the answer, and everyone understand how this has to be done. We'll have to use the formula of relation between beta and alpha. Do we remember this formula?
Sir.
Yes, sir. Then put the value, sir, and get the answer, sir. Remember, alpha is always less than 1. Do we remember this?
Yes, sir. Less than 1.
Yes. Oops, my pen has lost confidence. It has gone. Okay, now it's back. Alpha is always less than 1. Beta is always greater than 1. Beta is very high. Common emitter gain is very high. Do we remember this?
Yes, sir.
But when it becomes common base, the gain is very less. Alpha is only 0.98. So will you remember this every time?
Yes, sir.
All of you could do this. Again, it all depends on whether you remember the relation or not. If you don't remember the relation, bacha, everything goes down the drain. Can we move on to the next question, please? Yes or no?
Sir.
Yes, sir. Again, sir, this question is from your exercise, sir. Calculate the emitter current, sir. Base current is 20 microampere. Beta is 100. Always greater than 1. Beta. My beta. Let's see who does it for me. Again, a minute to win it. Remember, they are not asking you the value of alpha or gamma. They are asking you the value of emitter current. Let's see if you can do this for me. Anyone with an answer? No? Sad. This is so sad. What is the problem? Can anyone tell me what is the problem? Who will tell me what is the problem?
Answer is 2.02.
Answer is 2.02. I hope you have solved it on your own and not seen the solution. Yes or no?
Yes, sir. Somewhat.
Somewhat or full what?
Somewhat. 60%. 60 to 70.
No, 60% will only give you -1 mark, beta. Do you know this?
Yes, sir.
Only 100% will give you +4. Otherwise, it is -5. Do we remember this? Do we understand this?
Okay, sir.
60% will give you how much? -5. 80% will give you how much? -5. 90% will give you how much?
-5.
-5. 99.1% will give you how much? -5. 99.999999999999999999999 will give you how much? -5. Only 100% will give you +4, and it's all about +4 that we are dealing here. I don't think about negatives in my life. So you just remember what is beta? Beta is the current gain in common emitter. It is IC divided by IB. Yes or no?
Yes, sir.
From there, you know the value of IB. You can calculate the value of IC. Yes or no?
Yes, sir.
From there, I got the value of IC as 2000 micro ohms. Microamperes. Yes or no?
Yes, sir.
Then I put the simple formula IE. Emitter current is base current plus collector current. 20 plus 2000. Answer is 20,000. 20 microamperes. Do we have any doubt left in your head?
Yes, sir.
Yes, sir. Doubt left? What doubt left?
Nothing, sir.
Nothing, sir. Can you move on to the next question, sir?
Yes, sir.
Payal, Pooja, Kajal, are we there in the class? I mess up names. That's why, yes. So I call everyone as Bacha and Beta and Betis because that is common. Everyone is a Beta and a Beti, right?
Yes, sir.
Names may be confusing. So that's why everyone becomes a Beta and a Beti. Okay, Bacha. So let us move on to the next question. And again, if you don't remember this, you don't remember the formula, you are done and dusted. 99.999 gives you -5. So give your 100% and solve this one. Again, question on similar lines. You can solve this. That means you have understood the entire topic. You might not have understood the entire topic, but you remember the formulae for that. The formulae, I have made you understand how those formulas have come. So I'll give you a minute again. Let's see who solves this for me. In quota, we have a term known as chocolate question. Have you heard this term, chocolate question? No, there is a series known as Quota Factory in Netflix. It was previously on some other channel. That series has been written by a friend of mine who's also a teacher. So he has written that series. Have you seen that series, Quota Factory?
Yes, sir.
Yes, sir. So that series has been written by a friend of mine. He's also a relative, and they used to work there. So I also had put some input in that series. Okay. So what I was telling you, in that series you see chocolate questions. Yes. First
Yes,
part,
sir.
chocolate question, chocolate question. This is the chocolate question for you. You'll not get a chocolate right now, but I'll send it to your hostel. I'll courier them to your hostel. Order them and send it to your hostel. But again, the amount has to be more. They will not deliver a single chocolate. Yes or no?
Yes, sir.
They will not deliver a chocolate worth 20 or even 100 rupees. So make it at least 10 chocolates and I'll send it to you. Chocolate question number 1. If you can do this, you get 1 chocolate. And then you share among yourselves. Whatever part you get, each one keeps that part. For a common emitter amplifier, current gain is 50. Emitter current is 6.6. Calculate the collector base, everything calculate. Also calculate current gain when the emitter is working as common base. So they are asking you the value of which one? Alpha. They're asking you the value of alpha. And they've given you the value of beta. Let's see who cracks it. One of the famous institute says, let's crack it. I don't think anyone studying in that institute has ever cracked it, but we will crack it. So let's, instead of cracking it, let's crush it. That's our heading. Let's crush it. Let's crush this question up. A minute is all you have. And if you are sitting watching my face is not worth watching. Triple R Hero, Junior NTR and Ramcharan, watch their faces, not mine. Solve the question. All heads should be on the table, not on the screen. Yes, bacha, do you need any help? Shall I help you?
Yes, sir.
No, sir, you should not need any help. Because if you're always looking for help, bacha, you will never become self-reliant. And even our Prime Minister says that we need to have what? Atmanirbhar Bharat. If you guys don't become Atmanirbhar, how will Bharat become Atmanirbhar? No, Bharat will not become Atmanirbhar. It will become dependent. And you have seen what happens when you become dependent on other country. You become Sri Lanka, right? Or you become our neighbors. All our neighbors are in fizz, are busy because they have been taken over by foreign countries because they have depended too much on them. And if you do depend on me, I am not going to save you in the examination hall. I will not come and solve questions for you here. Kajal, are you there? Trying to solve the question? Pooja? Pooja is not there. She's in dark, I think.
Not understood, sir.
Yes, beta. Are you trying to solve the question? Yes or no?
Yes, sir.
Yes, yes. Solve. Don't look at the screen. There's nothing on the screen. The question is on the screen. Look at your table. Okay, shall I help you? I don't have enough time. We'll have to move on. So, common emitter, current gain. So, what value is given to us? Tell me what value is given to us. We are given the value of beta. Yes or no? Yes or no? We are given the value of beta because this is common emitter configuration. We are given the value of beta. Beta is IC divided by IB. Yes or no?
Yes, sir.
From here, I can find the relation between IC and IB. IC will become 50 times IB. We understand this?
Yes,
Then
sir.
we know this equation IE will be IC plus IB. I just put the value of IC here. I will get the value of base current. Yes or no?
Yes, sir.
Simple calculation. The base current will be coming to you. Once the base current comes, you can multiply it by 50. You will get the collector current. Base current is known. Collector current is known. Then they are asking you, what will be the current gain when it is working as common base? Common base, that means it's asking about alpha. You put the relation between alpha and beta and you should get your answer. You don't have to do so much. You can simply put alpha as what? Alpha as IC divided by IE. Do you remember this formula, bacha?
Yes, sir.
If you put that formula also, you will again get the same result. Do we understand this? Yes, sir. No, sir.
Yes, sir. Yes, sir.
What was the problem, sir, then? Now tell me what you did not understand and where you were stuck so that I can help you out. At what stage were you stuck? Tell me, anyone. Sir, we were stuck at this stage. We could not solve after this. Tell me. Tell
Understood,
me
sir.
now. Don't be shy. Everyone makes mistake. I made lot of stupid mistakes in my life. Some mistakes I can't even tell you. Once there was a generator and I was trying to clean the drain of the generator and I opened the fuel inlet pipe and the entire ship was burning literally. So everyone does stupid mistakes. Yes. What we did not understand. Calculation. What? Okay. Can we do the next problem then? Can you move on to the next problem?
Yes, sir.
Again, problem based on similar concept. We are doing 3-4 problems on the same concept so that even if you can do any one of these, you have done all of these. So again, a chance to redeem yourself. You are like cash vouchers that you get when you shop at different shopping sites. They give you vouchers, cash vouchers. You can use them later on. So now it's the time to redeem your voucher. If you can solve this question, that means you can solve the other 3 also. Redeem yourself. And I'll give you a minute to redeem yourself. Is a minute enough? I don't see the confidence. Is a minute enough?
Yes, sir.
Yes, sir. Solve the question, sir. The question is pretty simple. Beta is given as 75 and it is connected to common base. Remember, it is connected to common base. What will be the maximum collector current? Emitter current is 5 milliampere. So IE is given to you, beta is given to you, and it's given that it is common base configuration. Can you tell me what is the collector current? Your time starts now. This is probably the most difficult question that you will get in your exam. If you can solve this question, that means you can solve all the questions that can come to you. A minute to win it. Is everyone solving the question or having a tea party there?
Came, sir, answer.
Getting the answer, sir?
Yes, sir.
Well done, sir. Tell me, how did you do, sir?
First we find alpha, sir,
First we find alpha, sir. Okay, sir.
and we divided it in alpha is equal to IC square by IC by E.
Yes, that is correct. Well done, bacha. I hope all of you can understand what he has said. We know the value of beta. We know the value of emitter current. From beta, you can find out the value of alpha. Alpha is beta upon 1 plus beta. 75 by 76 is your alpha. We also know alpha is IC into IE. So IC becomes alpha times IE, and you have your answer 75 multiplied by 5 divided by 76. When this question comes in the examination hall, they might not give you this, they might give you this. Do we understand this?
Yes, sir.
Can I have raised hand from everyone in the class that we understand this? Well done. Everyone is looking quite jolly today. Good, Maggie. I'll recommend that they give you Maggie every day. Let's see if that's possible. Last question from this exercise, and after that we'll move on to simpler questions. And when I say simpler question, I mean the question that have previously come in the examination hall. The questions that we are doing are a lot tougher. The last one in this category, I hope everyone does this. A minute to win it. No tea parties here. Please do the question. Anyone with any answer, sir?
Yes, sir.
What is the answer, sir? For the first part, A, sir.
For beta, it is 30, sir.
Well done, sir.
For alpha, 0.97.
That is correct, sir. And what about emitter currents?
Sir, I is not coming, sir.
Okay, so you just have to divide. So let me. What?
Formula is confusing.
No, formula is not confusing, beta. Formula
I
is
is
not
equals
confusing.
to
Formula
I
is very
equals-
damn simple. I will tell you, don't worry. So we are given the value of, we are given base current, and the
Yes.
collector current is 3 milliamps. One is microamp, one is milliamp. You can find out the value of beta IC divided by IB. Do you understand this? Raise
Yes,
hands.
sir.
From there, you get the value of beta. You know the value of alpha is beta divided by 1 plus beta. So you get the value of alpha as 30 divided by 31. Yes or no?
Yes, sir.
Then your alpha is IC divided by IE. So IE becomes IC divided by alpha. What is confusing here?
Sir, once again.
Nothing is confusing. It's just simple division. If alpha is IC divided by IE, can't you find out the value of IE?
Yes, sir. Yes, sir.
This is third standard, not third standard, maybe fifth standard question. I can't tell you, I can't take you back to fifth standard because that will be way back in the past. If I go and do something stupid there, your entire future will change. I can't do that. I can't go back to fifth standard. From there, you can
Okay.
calculate the value of IE. Yes or no?
Yes, sir.
Yes, sir. Let us remain in the present. This present is good enough. So from there, you can get the value of IE as 3.1 milliamps. Then the next question, this is how the question might come in the examination hall, and that is why we have done this. A change of current 20 microamps in the base current produces a change of 0.5 milliamps in the collector current. Find the value of beta AC. Remember, up till now, what we were doing were DC things. For AC, it will be change in current. For AC, it will be change in current. For AC, it will be change in current. Doesn't matter. The formula remains same. Instead of base current, we will call it change in base current. Do we understand this?
Yes, sir.
I need all your hands in the air. Hands in the air. When AC comes, we don't have base current. We have change in base current. Okay. So change in base current is 20 microamps. Change in emitter current is 0.5 milliamps. Just divide change in collector current divided by change in base current, and you get the value of beta. Do we understand this?
Yes, sir.
The language has changed. The language has changed, but the formula remains intact. Can I trust you that you will be able to do this for me now?
Yes, sir.
Yes, sir. No, sir. Everybody is on the same page, sir. Everyone understand this, sir, or not?
Sir, for IC 3 into 31.
Yes.
For I is equals to IC by alpha.
Yes.
3
What's
into
up?
31 by 30.
Yes. Correct,
3
na?
into, 3 into 31 house.
I can't tell you that. If you can't divide a number by a fraction, that would be a problem, bacha. IC divided by alpha. Alpha is 30 divided by 31. So that 31 will go in the numerator na, yaar. This is fourth standard stuff, beta.
I am asking 3 into 31, sir. How 3 into 31?
How 3 into 31? How 3 into 31? Because 3 is collector current, bacha.
Collector current.
Yes. Do you understand this? 3 is collector current. Take 1 minute off. Take 1 minute off. Close your eyes. You know the value of IC. You know the value of alpha. Divide it in your head. Divide it on the pen. And I'm sure your doubt will be clear. Do we understand this? There's some
Okay,
things that I can't tell you. I can't tell you A is for apple. Because A is for apple. So I don't know this. Problem.
okay, sir.
Think. IC is 3. IC is 3. Alpha is 30 divided by 31. 30 divided by 31. I have to find out IE. IC divided by alpha. Divide it. You'll get your answer.
Yes, sir. Got it.
Got it, na sir? I have not helped you out. It's just you who has closed your eyes and thought about it. There's something that you will have to understand on your own. Bacha, I can't tell you how to divide things. Can I tell you how to divide things at this point in time? No, don't expect that I will help you with everything. Because if I help you with everything, at the examination hall, you will be crying, sir, come and solve the question for us. That cannot be done because that is illegal. And I have no intentions of becoming a doctor now. I've lived my life happily. Shall we move on to the questions, please, now?
Yes, sir.
Then, as you can see, same question with the same sort of language comes to you. Can you give me the answer for this one? Transistor has an alpha of 0.95. It has change in emitter current is change in emitter current. Change in emitter current is 100 milliampere. What is the change in the base current? Can I have your answers, please? Question number 61. And these are the questions that will come in your examination hall. Alpha is given, change in emitter current is given. They want you to find out the change in the base, change in the collector current. Can I have your answers, please? M standing for milli, so you must know that. Yes, bacha. I'm not getting any answers. That is strange. I thought that I'll get an answer straight away. Everyone seems confused. Shall I solve it for you then? If everyone is confused, I will have to step in. Shall I solve it?
95.
You can't do this? Okay. Then I'll solve it for you.
Sir, 95.
Yes, 95 is the answer, bacha. It is as simple as that. 95 is the answer, bacha. How do you do it? Alpha.
Alpha is equals to IC by IE.
Instead of writing IC, I will write it change in IC divided by change in IC. Is it okay?
Yes, sir.
I told you that just now. Yes or no?
Yes, sir.
So change in collector current, it is simple multiplication. That will be equal to alpha multiplied by change in emitter current. Do we understand this? Can I have reasons from all of you?
Yes, sir.
Multiply 90.95 by 100 and that is your answer. So the answer is 95 milliamp. Do we understand this?
Yes, sir.
All of you. And these are the simple questions that will come, bacha. Please. All these questions are +4. Don't make it -5. I'm putting a lot of effort here. I know 2 or 3 questions are going to come from here. Please don't make it -5. Please don't make it -5 because these are the simplest questions that you can ever see in your life. Please don't make it -5. One more. Let's see who does this. Question number 60. For a transistor in a common emitter arrangement, the alternating current gain, remember when it is alternating, it is always changed. Alternating current gain beta is given by the following formulae. Yes, the correct answer is
C.
The correct answer is B. Well, you must take
C, sir, answer.
which one, beta?
C.
Yeah, C is the answer. If you tell me B, I would have told you some very nasty things that you have become Amir Khan of Ghajini, and he might look good on TV, but that would not look good in the examination hall. Yes or no?
Yes,
If
sir.
all of you become Ghajini, shave your head off, and you write things on your body and go to the examination hall that I will read from my body and write it in the paper, that will not work. Yes or no?
Yes, sir.
Because NEET has a dress code. You will have to put in sleeves up till here so that you can't write anything on your body. Don't become Ghajini in the examination hall. Remember what we have done. Do you promise that you will remember?
Yes, sir.
Yes, sir. Because if you don't remember, then what will happen, sir? Is that I will forget it. Now let us see who can get into AIMS. So this is a question that will get you into AIMS. Let's see who is going to AIMS. This question will get you into AIMS. All India Institute of Medical Sciences, if I am not wrong. So this is a question from AIMS. Some time back, AIMS had a different examination. Now it is not there. Consider an NPN transistor amplifier in a common emitter configuration. The current gain of the transistor is alpha. The collector current changes by 1 milliamp. What will be the change in the emitter current? This is how questions are framed. God bless you. I want to see all of your names. Let's see who is going to treat me when I get older in AIMS. Again, you get a minute. You should not even get a minute for this. Yes, bacha. My hands are trembling. I need someone in names. Who is there? Girls are definitely not there.
1.01, sir.
1.01. So the answer is B. Yes or no?
Yes, sir.
Yes, you are getting into AIMS. So thanks for getting into AIMS, and I will be coming and getting myself treated over there. 1.01 milliamperes. And how did you do it? Tell me, bacha. It's a common emitter
In
configuration. So they've given you the value of what? Beta. Yes or no?
Yes, sir.
Beta is given as 100. Collector current is given as 1 milliohm. You have to find the value of emitter current. How will you get the value of emitter current? First, you will get the value of base current. Yes or no?
Yes, sir.
And then you will add base current with the collector current. We have done this many times, and the answer that you will get is 1.01 m. So what are the two formulas that you have used here? You have used the first formula. Beta is IC by IB. Yes or no?
Yes, sir.
That is the first formula that I have used. Then you have used emitter current is IC plus IB. Both these formulas put together, and you get your answer, and you get into AIMS. Yes or no?
Sir.
Yes, sir. No, sir. What comes next, sir? Let's see who solves this one, sir. 10 marks question this was. Oh, 10 marks. Let's see who gets 10 marks here. A common emitter amplifier has a voltage gain of 50 and input impedance. Impedance is nothing but resistance. We will study impedance in AC, and that is the next topic that we are going to do. Don't worry about that. We will cover it. The input resistance for now is 100. Output resistance is 200. Can you now tell me the value of power gain and get 10 marks and stay happy always? Again, you have to look back in the past and look back for the formula. That is not good. You are all becoming Ghaznis. Not good. You can't become Ghaznis. We have to become someone who remembers everything, which is definitely not me. I forget names. I forget dates. The only 2 dates that I remember is my birthday and my son's birthday. There is not even a third day that I remember. Don't become me. Don't become Ghazni. Remember what you have studied. Pooja, are you doing okay? You seem confused. Okay. Kajal, okay. I get confused between Pooja and Kajal. Kajal is back. Pooja is in front, looking at the screen. See, question answer is not going to come out of the screen, beta. Answer is going to come when you are going to do this. It's not going to jump out of the screen. There was a very famous scene from a very Purana movie where Mr. Nasiruddin Shah was coming out of a picture poster and the dialogue was Fata poster Nikla hero. So इस पे picture ही बनी है फटा poster निकला hero. But I cannot jump out of that screen and come and write in front of you, or the answer is not going to jump out. So fata screen nikla answer is not going to happen. Answer is going to niklo when you do the question, then only the answer is going to niklo. If you don't do the question, answer will never niklo. What are the formulas that we have to use?
P naught by Pi.
P naught by Pi. Well done. Is output power given to you? No. Is input power given to you? No. Is output resistance given to you? Yes. Is input resistance given to you? Yes.
Yes.
Is the current gain given to you? No. Is the voltage gain given to you? Yes. Put all these things together and you will have the answer. Okay. This might look a bit confusing. It is not confusing, beta. That's why it was given for 10 marks. It's not confusing. Do we remember this formula?
Yes, sir.
Power gain in common emitter circuit, yes or no?
Yes, sir.
What was this beta here? What was this beta here?
V naught by V.
This was current gain, yes or no?
Yes, sir.
But here current gain is not given to us. Voltage gain is given to us, yes or no?
Yes, sir.
So now I am giving you one more chance to redeem yourselves. One more chance to redeem yourself. Instead of current gain, voltage gain is given to you. Now I'm showing you the screen where we have both current gain, voltage gain, and power gain. This is the screen that is going to help you solve this problem. Now I've given you all the raw material that you need to solve the problem. This gentleman is your voltage gain. This gentleman is your current gain. And this gentleman is your power gain. Can you now put all the blocks together and get me the answer, bacha? Can you do it or shall I do it for you? From here, I can find the value of beta. How much will be beta coming as?
100.
How much will be beta coming as?
100.
Current gain, voltage gain into Ri divided by RL. Yes or no?
Yes, sir.
And then I can put the value of this beta in this equation. Can you do that for me? Can you put the value of beta from here to there? From here to here. Can you do that? So what will be my power gain? My power gain will be equal to इसका square करना है. Do we understand this?
Yes, sir.
Yes or no? So it will be AV का square into RI का square divided by RL का square. Do we understand this?
Yes, sir.
Multiplied by RL divided by RI. Do we understand this?
Yes, sir.
One RI will get cancelled. Do we understand this?
Yes, sir.
One RL will get cancelled. Do we understand this?
Yes, sir.
So now I have a new formula. Now I have a new formula. Can you now tell me what is that new formula that we have just now devised? And that new formula will get you 10 marks. There is no question of 10 marks these days. Anyways, that new formula will give you the answer for this question. What is the new formula that we have devised?
AB square R.
The original formula is power gain is beta square into RL by RI. Yes or no?
Yes, sir.
But now I have devised one more formula where instead of beta we have voltage gain. Yes or no?
Yes, sir.
What is that formula, bacha, that we have just now discovered? This formula AP, the power gain is also equal to voltage gain squared. Yes or no?
Yes, sir.
And then we reverse RI and RL, so it becomes RI divided by RL. Yes or no?
Yes, sir.
Now can you tell me the answer, bacha? Can I have the answer now, bacha? Still no? Still no? AV is 50,
1250, sir.
RI is 100,
1250.
RL is 200.
1250, sir. Answer.
The answer would be 1250. It should not have taken so much of time, but it's okay. New question, and that is why I have done this. Just to give you confidence that all the questions that are coming or have come are from the same concept. Do we understand this? Can I have some raised hands?
Yes, sir.
Okay. I think we have enough time to do one or two more questions. Anyone has any doubt in this question? Please let me know.
No, sir.
No, sir?
No.
Let me see if I have. Yes, again, a simple question based on a simple formula, and this one comes to your screen now. A transistor is operated in common emitter configuration at constant collector voltage. It's always constant collector voltage, so that a change in base current from 100 to 150 produces a change in emitter current from 10 milliamps to from 5 milliamps to 10 milliamps. What is the value of the current gain? Will you do this for me? Are we confident? I don't see the
sir.
confidence. No one is confident. No, no, no. Yes, Pooja and Kajal, my favorite students, are in confidence. Everyone is my favorite student. I don't remember the name of Pooja and Kajal and Sonu Sood.
Yes, sir.
Yes, sir. So don't understand why I put Sood in front of your name. I have a very peculiar habit of once I hear the name for the first time, whether it is anyone, Urmila. So whenever I see a next Urmila, it will be always Urmila Matonkar, because that is the first Urmila that I've heard. Right? So I had a friend, I have a friend Nitin Saxena. So whosoever I meet in, whosoever is Nitin, it's always Saxena. There cannot be any other surname. Do you understand this? My
Yes,
way
sir.
of, my way of whatever. So if someone is Aishwarya, by name of Aishwarya, it is always Aishwarya Rai. Whatever surname she has doesn't matter. For me, it is always Aishwarya Rai. Got it?
Yes, sir.
Yes, sir. So Sonu Sood, sir, get me the answer, sir. As far as Pooja is concerned, I have a friend called Pooja Agarwal. So Pooja is Agarwal. So when I say Pooja, it means Pooja Agarwal, right? Kajal, I never had a friend named Kajal, so Kajal remains Kajal. Okay. Any answers? No answers? Not good. Remember, 99.99999% will still give you -5. Shall I have the answers, please? Change in base current is given, yeah. Change in collector current is given. You can't find out the value of beta. You are shaming Junior NTR and Ramcharan both together. They are killing villains with bows and arrows, and you just can't find the answer here. Shame. Shame, 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 shame. Tell me, what is the value of beta? Change in what? Change in collector current divided by change in base current. Yes or no?
Yes, sir.
You cannot subtract and divide. Shall I tell you how to subtract and divide?
Beta is equals to 50.
What is the answer for 76? Are?
Sir,
What is the answer, bacha? Change in emitter current is 5 milliamps. So 5 milliamps divided by change in base current is 50 microamps.
yes, sir.
50 microamps. So this is the answer. The only thing is the difference in the units. Milli is 10 raised to the power -3. Micro is 10 raised to the power -6. You just have to multiply and divide, bacha. What is the answer that is coming, bacha? Don't even to multiply, divide. 67 is not going to come. 75 is not going to come. 50 is not going to come. The only option is
100.
100. You don't have to even convert. You use your brain. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, a parting question, sir. And let me do this question. And this has got nothing to do with what we have done today in the class. This has got everything to do that we had done yesterday in the class, because this is the latest question that I have, and that comes here. Here. Let's see who does this for me. You have a minute to win it. You can't get -5. You have to get +4. Consider the junction diode as ideal. The value of current flowing through the part AB is how much? Question number 91, one of the last questions in this series. Will the diode conduct or not? What is the first question? Will the diode conduct? Is that the diode forward biased or reverse biased?
Forward bias.
So it will conduct. To just find out the potential difference and divide it by the resistance. What is the answer?
10 to the power of -2.
10 to the power of -2. That is absolutely correct. And these are the type of questions that are going to come in your examination hall. Are you confident that you will be able to crack them? No, I will not say crack them. Are you confident that you will be able to crush them?
Yes, sir.
Crush them. Yes, sir. So one more question, sir, on this high point, sir. And it is exact replica of the question that we had done previously. Now, again, you have one chance to redeem yourself. You are just like cash vouchers. You can always redeem yourself. Same question, as you can see. Those people, they don't have time to even change the language of the question. They might not even change the value and put the same question. Can I have the answer for this one?
50, sir.
50, sir. 86, sir. That is correct, sir. So do we understand how questions are framed? Yes or no?
Yes, sir.
Well done. One more question that you must know as information, and that is why I'm sharing it with you. So this question comes, then just mark it and stay happy. And this is the question. The device that can act as a complete electronic circuit is complete circuit. Now, how do you solve question of this nature? Small tip, small hint. You know what does a Zener diode do? Yes or no? It only operates, it's just a device, it only operates in the breakdown region. Yes or no?
Yes, sir.
A junction diode only acts as a switch. Either it allows current or it does not allow current. Yes or no?
Yes, sir.
You also know that transistor does not act as a complete electronic circuit, the only thing that you've not heard about is,
Integration diode.
and you remember this in your end. Got it this?
Okay, sir.
Okay. The only confusion here in this question would have been between integration diode and junction transistor. But when I say junction transistor, they only say PNP. Only one PNP device cannot act as a complete circuit. Yes or no?
Yes, sir.
Zener diode or junction transistor, they are just a device. They cannot form the entire circuit. The entire circuit is formed by the integration diode. And on that note, on that high note, I will be ending up this class. And in the next class, what we shall be doing? What we shall be doing in the next class? Tell me.
Logic
Do you know what is there in the future? Tomorrow, what is going to happen? Yes, tomorrow we are going to do this. That comes on your screen right now. Right now, it not make. Right now, it not make. It may not make more sense, but after tomorrow, you will be able to solve this. This is a trailer.
Sir, we have not done feedback.
We have not done.
Feedback.
Do it as homework. Feedback is, what is the feedback? I am teaching you. I am teaching you, and you are telling me how I am teaching you. That is the feedback. Yes or no?
Yes, sir.
That is feedback. Nothing else.
Transistor in an oscillator.
That is only for 12 board. That is not in your NEET. Don't worry.
Okay, sir.
Feedback, you can do it as homework or not. You can just read what is feedback.
Okay, sir.
Yes or no?
Yes, sir.
Yes, you are intelligent enough to do this. If you want, I'll give you a brief outlook of what is the feedback. That will not harm anyone. I will just go through this. A feedback is something when you have an output. Say, for example, I give you some input and you give an output. If I take
5 ampere current.
5 ampere current and 10 ampere is the output. So I have to check whether the output is correct or not. So what will I do? I will take a part of that output and put it back into the input. That becomes a feedback. Yes or no?
Yes, sir.
A positive feedback. If you give positive feedback for me, the institute people will be happy.
Yes, sir.
When input and output are in the same phase, so I and you are in the same phase, whatever I am teaching you, you are able to understand. That is positive feedback. Yes or no?
Yes, sir.
That is an oscillator. So we are an oscillator circuit. We oscillate. That's why we move hands. Negative feedback, if you tell me sir is doing bakwas all the time and he does not teach us, we are out of phase and it is a negative feedback. Got it? So we don't want to become a gain amplifier. We want to become an oscillator. Do you understand this?
Yes, sir.
That's all about feedback that you must know. Where it is used, positive feedback is used in oscillators. Negative feedback, not good, is used in current gain amplifier, constant gain amplifier. Shall we wind up the class now? Shall we shut shop today?
Okay, sir.
In the next class tomorrow, we will be dealing with logic gates. A gate
Sir,
which works on logic. Yes, bacha?
Weekend syllabus.
I have no idea. I have not been asked to make the question paper till now. So weekend syllabus. Syllabus is always what we have studied till now.
Okay.
So everything is a part of the syllabus.
Okay.
We can't ask for syllabus now. After 2 months, you have exam. What will be the syllabus of the exam?
Total syllabus.
Everything now?
Yes, sir.
Yeah, so everything, what we have done up till now, everything is coming.
Pooja is asking, sir.
Pooja is asking, syllabus of the exam. Pooja, everything that we have done so far is the syllabus of the exam.
Kajal also asking, sir.
Kajal also asking, Kajal, same answer.
Both girls.
You ask the same question, you will always get the same answer, beta. You will not get different answer for the same question asked by different people. I am not a politician. That if one journalist asks that question, I will give you a different answer, and the other journalist asks, I will give you a different answer. No, the answer remains same. Answer does not change.
Okay.
That is physics. Physics answer remains same. They don't change. I am not a politician. I don't change my answers. Got it?
Sir.
Chalo, sir. We'll meet in the next class, sir. Have a good day, sir. Enjoy your meal, sir. Take care, sir.
Okay, sir. Take
Bye,
care.
sir.
Bye, sir.
I like the way she waves his